Hello everyone, I'm Lantzanakis, a PhD candidate at the University of Freiburg and a member of Remote Sensing Lab of Fourth. My PhD research focuses on multiscale identification and mapping of urban surface radiative and thermal properties, and is being conducted in the frame of Synergy Project Herbisphere, funded by European Research Council. Urban sustainability and resilience depends on cities' adaptive capacity in response to ongoing urbanization, weather extremes, and climate change. The urban energy balance is dependent by the urban materials, which exhibit special variable spectral radiation responses associated with material composition, structure, texture, and other properties. As the spectral reflectance and the thermal emission affect radiation exchanges and other biogeochemical processes, these data are fundamental for many different applications, like weather and climate modeling at different scales. My PhD thesis aims to understand and simulate the radiative and thermal properties in a complex urban environment, providing data for modeling at different scales, starting from individual buildings and small neighborhoods to entire cities and regions. However, in this presentation, I will focus only on the radiative part. So for this work, we carry out hyperspectral measurements in different European cities such as Iraklion, Berlin, and Paris using the high-specs camera to capture the majority of urban materials. We are looking for the tallest accessible building in each city, and we set up the camera over a rotated airport or we fly a drone over permitted areas in order to capture images from entire neighborhoods. Then, we collect the hyperspectral signatures from the images and organize them in the hyperspectral library with unique material variations under different characteristics and shapes. By collecting measurements at different angles, I expect to obtain a comprehensive dataset for the angular dependency of reflectance for each material of interest. This information is then integrated with the 3D structure of the urban environment using the 3D state-of-the-art radiative transfer model DART developed by CESBio in France. The DART simulations will be used to train deep learning algorithms for the conversion of the 3D material models into high-specs reflectant images at different angles and distances for the sun and sensor. Next, I will try to harmonize the resulting high-specs images with multispectral and hyperspectral images from different satellites such as Goldro-3, Sentinel-2, and EMAP. This effort aiming to extrapolate the radiative and thermal properties to the city and regional scale, providing the fundamental information I'm looking for numerous of application and climate models. However, there are several scientific and technical challenges, including the large number of campaigns required to cover the necessary material variation, shaded surfaces, atmospheric variation, specular reflection, transmitted surfaces like windows, and many others. All these challenges stem from the complex behavior of photons when they interact with different material types, structures, and shapes. So, at the end of the day, I just need to think about and understand what it looks like to be a photon in a complex urban environment and how it behaves under different conditions. Step by step, I'm confident that we'll achieve the best possible outcome. Thank you a lot for your attention.